Science is full of things that look obvious until you learn how they're actually measured. In this compilation, a clock defines deep time, images turn out to be defects, and even species boundaries can blur. The earliest internationally recognized geological period is defined by a clock, not a rock layer. It is the Siderian. The Siderian sits at the start of the Paleoproterozoic era, inside the Proterozoic Eon. It is the first named chapter in that span. Its boundaries are defined chronometrically, meaning by numerical age. The period runs from 2500 to 2300 million years ago. That gives the Siderian a span of 200 million years. After it ends, the Rhyatian period begins. So the first official boundary in that ancient stretch is a date, not a single rock layer. That is how deep time can be organized when one global marker is not enough. Eratosthenes was called beta, meaning second, because he was seen as never the best at any one thing. He was an ancient Greek polymath, working across philosophy, mathematics, geography, poetry, astronomy, and music theory. That range mattered because he was not a narrow specialist. He later became chief librarian at the Library of Alexandria. He also helped shape geography itself by coining the words geography and geographer. Geography means the description of the earth. So a man tagged second helped define an entire discipline, from Alexandria's library to the language used to study the earth. Dinosaur tracks near Lommiswil were studied with a helicopter, not just by walking the site. The site was too broad to read easily from one ground-level view. Separate prints can look isolated when you stand beside them. A helicopter gives an aerial view, which shows the track pattern across a wider area. That makes it easier to connect prints into one trackway. From above, the spacing and direction of the tracks become easier to compare. The same site turns into a readable map of movement. That wider view helps researchers document how dinosaurs moved across the landscape near Lommiswil. The footprints stop being scattered marks and become one visible route. Some 1950s celestial images showed transients that looked like temporary objects in the sky. Later, those same spots were traced to defects in Palomar Observatory photographic plates. A transient is a feature that appears briefly in an image and then seems to vanish. In these celestial images, that made the marks look like real sky events. The explanation depended on the recording medium, not on the sky itself. The photographic plate carried the flaw, so the image recorded a false object. Later analysis attributed the transients to defects in Palomar Observatory plates. That changed the reading of the evidence from an astronomical event to a problem in the image itself. The result is a reminder that celestial images can invent objects when the plate is flawed. What looks like a brief visitor can begin as a mark in the recording layer. An extinct oak relative called Phagopsis had fruit wedges that could be carried by wind. Phagopsis is known from preserved fossils, including a pictured example of those wedges. The shape was not just plant decoration. In fossils, that shape points to dispersal, meaning the fruit was built to move. Wind could carry the wedges away from the parent plant. That lets researchers read function from form. A preserved wedge can suggest how an extinct plant spread its seeds. So one fossil shape becomes a clue to movement in deep time. Phagopsis left behind evidence of a wind-based dispersal strategy. Broad-spotted molly males are used for sperm by a female-only species. That female-only species still reproduces, even though it has no males of its own. Its offspring depend on sperm coming from the broad-spotted molly. The mechanism is cross-species sperm use. The females take sperm from broad-spotted molly males, instead of relying on ordinary pair bonding within their own species. That creates a reproductive dependency across species. Without male sperm from outside, the female-only line cannot keep reproducing in the same way. So a whole life cycle can hinge on sperm from another species. The broad-spotted molly male becomes a necessary donor in a system built around females. Poecilia copperi and P. wandae blur genetically where they meet, even though they remain separate species. They meet in a contact zone, where populations from each species come into the same area. The blur is about ancestry, not just how they look. The likely cause is occasional hybridization, meaning some individuals from the two species reproduce across the boundary. That mixes genetic lines in the overlap. That makes the border less distinct in the overlap than in areas where each species stays apart. Genetic tests can pick up the blur even when shape stays similar. So the boundary between Poecilia copperi and P. wandae is real, but not perfectly clean everywhere. Where they touch, inherited DNA can form a softer edge. Many women with PCOS grow hair in a male pattern, and that can include facial hair. PCOS stands for polycystic ovary syndrome. It is a medical condition that can affect how hair is distributed on the body. In PCOS, the body can shift hair growth toward places that are more typical of male pattern hair growth. Facial hair is one visible example. That means the change is about hair distribution, not identity. The same condition can make the difference easy to notice in everyday life. So a common sign of PCOS can be a very visible shift in hair growth. For some women, the first clue is hair where they did not expect it. If one small fact changed how you see the world, the next 7 will do the same. Subscribe for more evidence-led stories, and tell us which one surprised you most.